Hello guys, welcome back to Bit Byte Kilobyte. Today we are going to go through some of the basic IDE features that you will be needing on your day-to-day basis for your coding. The first feature which I want to go through is breakpoints. So whenever you are developing a program, until it is ready, what we call that phase is in debug mode, right? So though you are not chasing bugs all the time, but you always run the program in debug mode, which you can see here as an option, which helps you to actually analyze the program while you are developing it and help you find out issues or how the flow is going from one function to another, what values are getting returned from your different methods, etc. So you can treat it as a more developer friendly mode where you can sneak and peek variables and values and stuff like that. So let's get started. The first thing is breakpoints. I've created this project where of course there's a main, and in this main I've created another test class. Ideally you should have this test class in a different file, but for the sake of explaining you so that you can understand how the flow is moving between different functions, I kept it in the same file. So what is happening here is I've created this test1 class, as I said, and I'm instantiating that class here. Okay, and this class has a constructor and it has function 1 and function 2. So in the constructor, I'm just writing that test object getting created because that's what constructor does. It gets called when the object is getting created. Function 1 we are calling from here, right from main itself. And from within function 1, I'm calling function 2 of the same class, right? So I'm calling function 2, and once function 2 is executed, I'm returning all done, the string, to the caller, and I'm storing this, the return value or the string, into a string type variable called return str. Now breakpoint means you are breaking that flow. Okay, so what we can do is if you go to this kind of a gray strip here, what you can do is you can click on it and there will be a red dot here or a red circle which will make the corresponding line also in red. That means your flow will break here. Okay, so to get started, let me put a breakpoint. Now if we run this, as you can see, the moment it gets started, our control stops here. So how do you know the control has stopped? Because you will see this yellow arrow in within this red circle, and the line, corresponding line, will be highlighted in yellow. Okay, so that means the program is currently executing at this particular line. Okay, so now what we will do is we will put a breakpoint here right when the object is getting created. We will put a breakpoint here when this is getting printed. I will put a breakpoint here as well, and at the end I will put a breakpoint here. Now let's see how the execution happens. So first, next it will execute this line, so it will stop here. Once you're stopping at a breakpoint, it gives you an option to continue. So I will run this. So as you can see, the first statement was creating the object. So while creating the object, the constructor got called, and we are stopping at the line where the text which I'm trying to print is getting printed. Okay, now if I run this, it will next stop here, but then this has already been executed. Right now if I go to my console, I will see that text object getting created is already printed. So here I'm now trying to print the value of I. The great thing here is with breakpoints, what you can do is you can actually at the runtime see the values of different variables, right? So here if you see I have passed 10, this is what has come into this parameter I, and if you see the value of I, it is I equal to 10. Okay, so you can add something called watches. Watch, as the name suggests, it will tell you what the value of this particular variable is at any point. Okay, so I can just right click and say add watch. Okay, the moment you do that, there's a window here that pops up called watch. There you will see the variable, the value, and the data type. Okay, now I will move on here. So here I have 10, so this should be printing function 1 got 10, right? And then it will call function 2 and the control will stop. at this line. Okay, now let me run this. So my control has now stopped here. By this time I should have already printed this line. So if I go to console, you will see function 1 got 10. Okay, so this is the line which function 1 printed. Now I'm at function 2 at this particular line. Again, you can do a quick sneak peek, just hover over the variable and you will be able to see the value of that variable. If you want to constantly monitor it, you can just right click and you can add another watch. So this gets added here. So I value was 10, J value was 5. Okay, now I will hit it again. Now it comes back to your calling program, and since everything is done, the return is all done, right? And that is what I'm going to print in the next line. So if I run this, my execution completes. If I go here, you will see first it printed object getting created, 10 and 5, and finally all done. So that's the benefit of breakpoints. Rather than you trying to figure out what's going wrong in your program, you can put breakpoints at important locations in your code and see the value of different variables using watches or by hovering over the variable to understand what is going on in your program. It is a very, very handy feature. We use it all the time during development. So make sure that you know this in and out. Okay. Now, before we move on, let's see, we put the breakpoint by putting this mouse arrow here, right? You click on it, there's a breakpoint that gets created, right? You click again, it goes away. So there's a keyboard shortcut for that as well. What you need to do is you need to press F9. So F9 is actually toggle breakpoint. So the cursor, whatever line it is on, if you hit F9, that line becomes a breakpoint and you can toggle it off using F9 again. So far, whatever we have done here with breakpoints, your control always stops as the execution comes to that point, right? So what if you don't want to do that, right? You want to stop the execution only under certain condition, right? So what I will do here is here I'm passing this variable always as 10, right? So instead of that, what I will do is I will read that value from screen first. So I will read a line here in this variable called str. What I will do is now I need to pass this here. Like in last chapter we saw, we need to convert the string to integer value, right? So what is the method for that? Int dot parse. So here I know that I will not be playing around with it. So I will use parse and not try parse. Okay. So I will put str here. So it will get an integer value for me, which I will be passing now. Now, what I will do here is instead of breaking all the time, I want this breakpoint to be applicable only when I am passing a value which is greater than 100. Okay. So what I will do is I will add condition. So if you go to conditions, what you will do is, if you see here, the first condition is conditional expression is true. So what is the expression? I'm saying stop here if I is greater than 100. So any value which is less than 100, the program will continue as is. It will not stop. Okay. So what you can do is now close this. So now if you see this breakpoint, it has a small plus sign to it, which indicates that it's a conditional breakpoint. So let me run this program now. Okay. The moment I enter 10, you saw it didn't stop. Now let me run it again. This time I will enter 200. But now it stopped because the value of I is greater than 100. This is also a very handy feature when you don't want your breakpoint to be hit all the time, especially helpful when you are within a loop. Okay, we'll get into loops in subsequent chapters, but loop is where you can run a set of statements again and again for until a particular condition is met, right? So conditional breakpoints are very handy if for a particular condition your program is breaking, you want to understand what is going on for that particular condition. You put a breakpoint there and put that condition as part of the breakpoint. So you don't need to like break every time when the program is getting executed, but it will just break when it's needed. Very, very handy feature. So the next thing with breakpoints is how you can quickly enable, disable all breakpoints. Okay, so suppose you have multiple breakpoints and we are just playing around with one file here, right? So you may have these breakpoints across multiple programs where you have put multiple breakpoints. If you want to quickly disable all breakpoints and you want to run your program without stopping anywhere, or suppose if you want to put another new breakpoint and you don't want the existing ones to be activated, what you would do is you will go to debug, okay, and disable all breakpoints. So once you do that, you will see that this has become a white filled red circle, all these places. So what has happened is the breakpoint is still there. It has not been removed, but it has been temporarily disabled. So now you can put your own new breakpoint, which you just want to execute. If you run this, I will put the value here as 10, and here it stops just on the new one, which I put. Remaining ones are all disabled. Okay. So the program will complete without hitting any further breakpoints. What you can also do is there might be a situation where whatever you were trying to triage or find or testing is now already done, right? So you want to just remove all the breakpoints. So in that case, you will go to debug and you will hit delete all breakpoints. So there's a shortcut for that as well, Control Shift and F9. And if you select yes, the breakpoints will go away. Another feature which is very, very useful is your ability to change value of certain variables while you are debugging. So either you are stopped at a breakpoint or stepping through the program, you have the ability to change value of certain variables. Okay, so let me show how. Here, I will run the program and it will ask for an input from me. I will enter it 10. Here, what I can do is, if you see the return statement is all done, before all done is printed on screen, what I can do is I can go here and click on this and say, instead of all, I can call it everything done. Okay, hit enter. So this variable now gets changed to everything done. Now, if you print this, run this program, what will happen is it will print everything done instead of all done. So you can do this to any variables while debugging or while stepping. Very handy feature if you want to change certain variables and see how the program is behaving without stopping the program and running it and compiling it again after making those changes. Okay, so now we know quite a bit about how our execution flows and how you can step through every line of your code. What I will do now is I will put a breakpoint here and show you another cool feature. So I hit a breakpoint and run the program. It's asking for a value. I put it in, I stop here. What you can very well do is you can actually go back to line number 9 here and execute that line. So to do that, what you need to do is you need to select that line, right click here and do set as next statement. Once you do that, the execution will go back here and will re-execute all the statements in between. So in our case, if we run from here, it will again ask for that number. I put that number again and it stops here, back again, right? That's a handy feature when you want to do some quick changes and you want to re-execute and see whether the changes are working or not. So what I will do here now is I will declare another variable, say j equal to 2. Okay. And now if I try to set this as next statement, it won't work, right? Because this was not in the compiled version. To do that, what you need to do is apply code change. There is this burning fire icon. You click this and now you go here and set as next statement. Now you see j, you can hit j here and now the j variable will have its value. So small changes like these new variable declarations or changing certain value of variables can be handled by this. This icon, apply code change, is also very handy. Apart from this, what you can do is you can also drag the execution just like this. You click and drag, it will take you to the line where you want to execute and you leave it there, it will start execution from there. Another handy feature when you are dealing with long functions is you can, instead of putting breakpoint, what you can do is you can just come to a line and you see this small icon here. It says run execution till here, right? So what it will do is even without breakpoints, it will just run till that point and stop for you. So this line we told it to stop. So you can see there is no breakpoint, but it's still stopped for you here. So this is a handy feature. You can also access this by using right click, run to cursor. It does the same thing. Control F10 is the shortcut key. Another handy feature which is often used by me is when you have a lot of classes, right? And suppose while debugging, you are in a particular class and you kind of lost where your execution is currently, right? What you can do is you can click on any line, right click and show next statement. If you do that, it will take you back to where you are currently executing. Very handy. So the next feature we will talk about is callstack. Callstack is a very important feature, guys. Please pay attention here and you will be using it. If you can use it while you're debugging, you will save a lot of time in debugging. Okay, so what we will do here is we'll put a breakpoint in this function right here. And we already understand the flow of this program. The first method that is getting called is main, of course. Main calls function 1 here and function 1 calls function 2. So that is how the call goes. Okay, so here I will run this and I will stop here. So it will ask for input from me. I will put like 10 and it stops here. Now, if you see that at this point you want to see what was actually passed to this particular function, function 1. You have no way to get that because you are here. If you go to I and try to see the value, hovering on top of it will not give you that value. And even if you go to the watch which you had created, it will say that I does not exist in the current context. So the current context is within this function. So I is not a variable which was declared in this function. Scope of I is beyond this. So you will not get the value of I. Okay. But however, if you see here in this window, it says callstack. Okay, in callstack, what it does is it shows you how your program calls had happened. So first the program main was called, then function 1 was called, and then function 2 was called. So on the top, whatever is there with a yellow arrow here, that indicates your current execution line. Okay, and these show you from where the control came from. If I want to see the value of I that was passed to this function, what I could do is I could find where this function was and double click on that. The moment you double click on that, it will take you to the point from where you had called function 2. Okay, so this is the point where we had called function 2. So it takes you back in time, kind of. Okay, so here once you come via stack, right, once you come via call stack, you can actually check the value that was passed to it. Okay, and even if you go to the watch, you will see the watch also has that value here. Okay, even now if I go to main here, you will see from where function 1 was called. So this was function 1 which was called from main. It will take you there. Here what you can see is what value I had entered on the screen. Okay, so here str I entered from screen. You can see the str value as 10. Here you are seeing return str as null because this function has not returned or completed execution yet. It stopped here. We are waiting for this, right? So once I return from there, that value will be passed and displayed on screen. So this is a very useful feature, guys. Please make sure that you understand this. Try it out yourself. You will use it day in, day out. If you can use callstack, there will be a lot of times when you don't need to really stop and put a breakpoint in the previous function and then run your program again. You will not need to do that if you know how to use the callstack. So that were few very frequently used debugging features that you will need on a day-to-day basis. Now, as we move on to more complex programs, I wanted to cover this so that when I do these while explaining you the code, you have an idea of what I'm trying to do. Okay, so use these in your day-to-day programming. These are extremely handy features that all of us should know. With that, we finally finish our 5-video long lesson 2. In the next video, we will move on to lesson 3. Now we'll move on a step higher and try to go through some of the conditional statements that C# language offers. So stay tuned for that. And guys, one more request before we wrap up. Please consider liking my video and subscribing to my channel and sharing it with your friends. That will really support the channel to grow and help me make more of such videos. Thank you very much for watching. See you in lesson 3.